The smallest number for which this occurs is called the period. Okay? Now for the sine and cosine functions, now to give you an idea of what's going on, remember we said the sine, so for, if we notice that what this means is the sine for any angle t, if we're in radians plus 2 pi, or for degrees plus 360, is equal to the sine of t, and the cosine of t, doesn't matter what t is, plus 2 pi is equal to the cosine of t. So we're just saying that doesn't matter. So an example, so let me do an example of this. Let's suppose we have 9 pi over 4. We want to find out what the sine or the cosine is of 9 pi over 4. Well, if I notice that 9 pi over 4 is equal to pi over 4 plus 2 pi, I can then take the sine of these, or the cosine equivalently, and this will just equal to the sine of pi over 4, which is equal to the square root of 2 divided by 2. I can just essentially, adding 2 pi doesn't do anything there. And to get an idea of why that is, we can start with pi over 4 degrees, pi over 4 radians. Then we have 2 pi over 4 radians, or the same as pi over 2. Then we have 3 pi over 4 radians, 4 pi over 4 radians, which is just pi, 5 pi over 4 radians, 6 pi over 4 radians, which is 3 pi over 2, 7 pi over 4 radians, 8 pi over 4 radians, which is 2 pi, and then we've gone around and we're up to 9 pi over 4 radians. So basically we've just gone around the circle once, and remember all that matters is the terminal side for the trig functions, and we stopped at the same place. So we can't have a different value for pi over 4 and 9 pi over 4 because they both have the same terminal side. And if you remember, that's what determines the value of the trig function. So it's in that sense, if that made sense, then that should make it clear that it has to be 2 pi periodic. Okay? Okay. So we're going to take a step forward, and we're going to look at graphing modified versions of sine and cosine. So we're going to look at graphing functions in the form f of t is equal to a sine of b of t, and f of t is equal to a cosine of b of t. So we're going to modify the functions a little bit. All right? Now we're going to note that if the absolute value of a is greater than 1, we have a vertical expansion. And if the absolute value of a is less than 1, we have a vertical compression. And if the absolute value of b is greater than 1, we have a horizontal compression. Yes, it's different than the a. You'll see why. And if the absolute value of b is less than 1, we have a horizontal expansion. Now, the reason, now, if a is bigger than 1, it should be obvious it's going to make the function bigger. If a is less than 1, it's going to squish everything together. Now, if b is bigger than 1, you're kind of, the reason you're having a compression is because you're getting to points on the graph faster, right? So you do not have to travel as far, say you're traveling between 0 to 2 pi, um, if if b were equal to 2, then you're going twice as fast. So to cover all your values, you don't have to go between 0 to 2 pi. You just have to go between 0 and pi, actually, to hit all your values. And you wouldn't have a 2 pi periodic function anymore. You would have a pi periodic function, which we'll see. So b greater than 1 means you're looking at the x-axis. It means you're traveling faster. If you're traveling faster, it means you're squishing things together. That's where you get a compression. And the opposite, so you can think of b kind of as your speed. If you travel fast, everything gets kind of squished together. You hit all your stopping points faster, if you want to think about it that way, or the points that you want to graph at, like say your quadrantals. You get to them quicker, and it's just everything. All right. All right. So let's look at an example of how we can do this. And we're going to say we're going to graph the function f of t is equal to 3 sine of t. All right. In this case, a is equal to 3 and b is equal to 1. So b is equal to, if a or b are 1, you don't have to worry about them. And I'm going to start out t, and I'm just going to use my quadrantals here, just save time, I guess. So my quadrantals are going to be 0, pi over 2, pi, 3 pi over 2, and 2 pi. So we have these. And then what we're going to do, and if you want, you can use pi over 4 also, and pi over 6, and pi over 3, and all the rest, if you like. 3 pi over 2. Oh, I do have 3 pi over 2. Okay, good. So then we're going to put our y value here because y is what the sine is. And when the angle is 0 radians, the sine is 0. At pi over 2, it's going to be 1. At pi, the sine is 0 again. 3 pi over 2 is negative 1. 2 pi is 0 again. And now I'm going to put my 3y over here. I'm just going to multiply all those values. Oops, don't want to cut that off. I'm going to multiply all those values by 3. So this is still 0. This is going to be 3. This is going to be 0. This is going to be negative 3. And this is going to be 0 again. So to get an idea of what this function actually looks like, it's just going to basically be our sine function, you'll see, except it's going to be stretched a little bit because a is bigger, so it's going to be stretched. And so the function 0 at 0 at pi over 2, we saw that now the value is going to be 1, 2, 3. So it's up here. At pi, it was still 0. At 3 pi over 2, the value of the function was negative 3. And at pi over 2, the value of the function was 0 again. So you notice now the range has changed because now it's negative 2 to 2. And negative 3 to 3. And again, we go the same way. It's still 2 pi periodic. That hasn't changed. All we've done is stretch it. So it's going to be negative pi over 2, negative pi minus 3 pi divided by 2, and minus 2 pi. So we're going to come over here, and at 0, it's an odd. Now we're dealing with an odd function still. All right, we're still dealing with the sine function. So we've gone from pi over 2 at 3, so a negative pi over 2 is going to be negative 3. And now it's going to be 0 again at pi, just using the fact it's an odd function. Then at 3 pi over 2, it's negative 1, so negative 3 pi over 2 is going to be positive 1, and 2 pi is 0. So the function looks something like this. My drawing is not great, but it's essentially what the function looks like, and that's f of t is equal to 3 sine of t. Okay? Alright, so the next one we're going to deal with is we're going to okay, so now we're going to look at another an example of another function, and for that one we're going to look at the cosine. We're going to look at the cosine of 3t. Alright, now for the cosine of 3t, what we're going to have is we're going to divide by b, as you're going to see. So we're going to start out as normal. I'll just do my quadrantals. So let's see, we have, and again, we're going to put down, we're going to do t divided by 3 because we're dividing. Whatever b is, you divide by it. So that's t divided by 3, and here's x because x is my cosine. Right? So my quadrantals are 0 degrees, pi over 2 radians, I'm sorry. It's going to be pi radians, 3 pi over 2 radians, and 2 pi radians. Okay? So now what I'm going to do is I'll fill in what my x's are. Well, at an angle of 0, my x-coordinate is 1. At pi over 2, my x-coordinate is 0. At pi radians, my x-coordinate on the unit circle, my cosine is negative 1. At 3 pi over 2, my cosine or my x-coordinate on the unit circle is 0 again, and then I come back to 1. Now what I'm going to do is I am going to divide each of these angles by 3. So when I have something of the form bt, I'm dividing by b. If b is 1, then t divided by 1 is t. It doesn't change anything. So 0 divided by 3 is 0. Pi over 2 divided by 3, or it's the same thing as multiplying by 1/3, is going to be pi over 6. Then we have pi divided by 3 is just going to be pi over 3. This is going to be 3, if we multiply by 1/3, it's the same as dividing by 3. The 3's cancel, so this will just be pi over 2. And then we just have, if we divide by 3, this becomes 2 pi over 3. Okay, so we've sped the graph up. It cycles through all its values now, not between 0 and 2 pi, but between 0 and 2 pi over 3. And to see that, if I just look at, say, before I graph it, if I look at, say, f of